Oh, hello everyone, welcome back to my videos. And in this mini videos, we're gonna cover the rest types of trig substitution with the tangent of theta. Okay, so in this scenario, we have the the integrals of uh, dx over 16 plus x squared to the power of 3 half. Okay. So the point is, if you want to rewrite these things a little bit, maybe we can rewrite this thing as this. So, okay. I mean, the power of 3 half is a little bit weird, but the point is, if you have the half in the power, you can translate into the square root. Okay. You have 16 plus x squared. Okay. And you still have the 3s over here. You can write the entire thing to the power of 3. So that's how you rewrite the powers of 3 halves. The half become the square root, and you still have the 3. So you just put the 3 into the the powers of the everything. Okay, and again, you still have the square root of something, and the point is you have the sum between two square. Okay, and the point is 16 is the perfect square number. 16 is 4 square. Okay, so if you have a sum between two square, if you have a sum between two square, you're gonna use the substitution with tangent of theta. Okay. So like I said, after you rewriting everything, you see that you have the square root of the sum between two square. You decided that you're gonna use the trig substitution where with tangent of theta. And the point is 16 is 4 square. So you're gonna put 4 into the front of your trig substitution. So I set up 4 equal to, I'm sorry, I set up x equal to 4 times tangent of theta. Okay, so after I do the substitution, I need to translate my integral in terms of x into the integral in terms of theta. So um, the x will be 4 times secant squares of theta, the theta, because the derivative of tangent is secant square. Okay. Okay. Now we can do this one. So now let's try to translate the integral in terms of x into the integral in terms of theta. Okay. And let me do this thing before we translate your integration into the integral in terms of theta. So from here, uh, you can say that 16 plus x squared will be 16 plus 4 times tangent of theta squared. And 4 tangent of theta squared is 16 times tangent of theta squared. Okay. 4 times tangent of theta squared is 16 times tangent squared. And 16, I can factorize 16. I have 1 plus tangent of theta squared. And 1 plus tangent of theta is secant squares of theta. Okay. Now we can rewrite the thing that we have. Dx is 4 secant square theta d theta. So 4 secant square of theta d theta. Okay. Divided by uh, the square root of 16 plus x squared to the power of 3. The point is square root of 16 plus x squared. I mean, the point is 16 plus x squared is 16 secant square. So I will rewrite this in this way. Square root of 16 plus x squared, and 16 plus x squared is 16 secant square. So I have square root of 16 secant squares of theta. Okay, and I write the powers of 3. Okay, power of 3. Okay, now let's simplify the function before we take the integral. The square root of 16 is 4. Okay, the square root of secant square is secant of theta. And one more thing, you still have the power of 3, so the powers of 3. Okay, so we have 4 secant square of theta is theta divided by 4 cube secant of theta cube. Okay, so you can simplify a little bit. 4 cancel out with 4 cube. You still have 1 over 4 square. Secant square cancel out with secant cube. You have 1 over secant. Okay, and 1 over secant is just cosine. And 1 over 4 square is 1 over 16. Okay, you have cosine theta, theta. So, before my bad handwriting, theta. The integrals of cosine is sine of theta. So you have 1 over 16 sine of theta plus c. Okay, so we finished with the integration. The last thing you need to do, you need to translate the function in terms of theta back to a function in terms of x, because initially your integral is the integral in terms of x. Okay, so that means if you want to translate this final result into something in terms of x, you need to translate sine of theta. Okay, the point is over here, because you want to compute sine of theta in terms of x. So again, you have to follow the thing you set up initially, and you need to use a bit of geometry to help you finish it. So over here, I will draw the right triangle. Okay, I will draw the right triangle. This is the right triangle what we have. This is the angle. Let's suppose this is the angle theta. Okay, this is the angle theta. Over here, I mean, you have x equal to 4 tangent of theta. This is the thing we set up initially. X equal to 4 times tangent of theta. So that means x divided by 4 is tangent of theta. Okay, and the point is tangent of theta is opposite divided by adjacent. Okay, tangent of theta is opposite divided by adjacent. So the things on the numerators will be the opposite. So I have, this is x, okay? The opposite side of theta is x. The adjacent side of theta is 4. So this is 4. This side is 4. Okay, and the point is I need to compute sine of theta in terms of x. Okay, so I need to compute the hypotenuse as well. So from here, by the Pythagorean theorem, the hypotenuse will be x squared plus 4 squared. Okay, the hypotenuse square is x squared plus 4 squared. That's the square sum of the two other side. Okay, this is the Pythagorean theorems. Okay, therefore, from here, so from the right triangle, we have, sorry, from the right triangle, we have that to compute sine of theta, you just need to take the opposite divided by the hypotenuse, which is x. Okay, the opposite side is x. The hypotenuse is square root of x squared plus 4 squared. You have square root of x squared plus 4 squared. Okay, so we have 1 over 16 of x divided by square root of x squared plus 4 squared plus c. So we finish our integration and finish translate the function in terms of theta back to something in terms of x. Okay, so remember that at some point after you finish your integration, sometime you have to use the right triangle to help you translate your function in terms of theta into the function in terms of x. Okay, you have to draw out the right triangle. Okay, so I will see you again. I will see you in the videos where we will work more exact. I mean, we're gonna practice more with the integration that we have to use the trig substitution. Okay.